T-minus 17 minutes and counting.
Go ahead.
The VFS pre-flight uplink load is complete.
Copy. CVFS.
CVFS copies.
Dumping of the Ops 101 program stored in the memory of one of the 4 redundant general purpose computers is now underway. That will take about 7 minutes to complete. Engineers will be examining that data for anything that would miscompare.
Go ahead, PLT.
Okay, horizontal fit. Yeah, Stan, horizontal fit config is complete, and we verified the OHM's interconnect config is also verified.
Okay, copy that.
Pilot Charlie Bolden has been in the process of configuring the cockpit switches for launch, and he's reporting that most of that configuration is complete. The airframe engineer is checking all of the critical movable aerosurface driver currents and is positioning all the hydraulic systems for activation.
TDSRO, go ahead, sir.
969, KSC area is clear for launch.
Roger, copy.
OTC PLT, MPS helium reconfig is complete.
Copy that. MPS OTC.
Yes, go.
Okay, you verify 945, 946,
Verified.
and 47?
Yeah, yes, sir.
Copy that. Double OS.
Go ahead.
Okay, configuring OHM's RCS cross feed for flight?
At this time, yes.
Copy.
Pilot Charlie Bolden has reported that the helium system reconfiguration has been completed. This opens helium isolation valves necessary for the in-flight purges of the engines.
Checking, sir.
Water levels in the water spray boilers are now being checked, and they are being verified to be sufficient for the mission. The NASA test director has asked Houston Flight to send their pre-flight uplink command to the orbiter's backup flight system. These loads are sent from the Mila tracking station here at KSC and put the 5th general purpose computer in the proper configuration for launch.
NTDSO 212.
Go ahead.
Yes, sir. Page 813, step 0965, normal track.
Copy.
Configuration of the cross-feed valves between the orbital maneuvering system and the reaction control system propellant tanks is being performed. The orbiter test conductor has asked pilot Charlie Bolden to report the quantities in the reaction control system propellant tanks. Meanwhile, the booster test conductor has been asked to start the gaseous nitrogen purge of the aft skirts. This flow of inert gas ensures that no explosive or flammable gases can accumulate in the bottom of the solid rocket boosters prior to their ignition. We're at the point now where all non-essential personnel are being cleared from the launch danger area. The white room has been closed out for flight, and the closeout crew has departed back to the roadblock.
MTDS, MT12. Step 986, sir. Copy. And FCP, OTC, here to ground 1.
FCP?
Yeah, your fuel cell purge complete?
Will be shortly.
Copy. Countdown clock will hold at T-minus 9 minutes and 4 minutes.
OTC, CFCP.
Go ahead.
Our fuel cell purge is complete and we're ready for fuel cell load adjustment.
Okay, EPD and ECL and FCP, adjust your fuel cell loads for the Ds.
EPD copy. FCP copies.
ECL copies. OTC, CVFS.
Go ahead.
T-minus 20 minutes, CPC dump is complete.
Copy that. CMQC is 979. Copy 979.
T-minus 12 minutes and counting, we've received word from White Sands that the weather reconnaissance aircraft there has advised that with the wind that they're seeing, there is still ample margin out there to cover any contingency in the event that we should have an abort once around. He has reported his observations to the chairman of the mission management team, Brewster Shaw, and Brewster has determined that weather at White Sands is go for launch. We've also received a verification that all of the contingency support is ready and that the aircraft and emergency teams are on station to support the launch today.
Copy that.
The T-minus 20-minute dump of the orbiter general purpose computer memory has been completed. We have no unexpected errors in that report. Now T-minus 11 minutes and counting.
Load adjust is complete. Copy that. ECL. ECL OTC.
Go ahead.
Yeah, can you agree with fuel cell? APD?
That's affirmative.
Copy. All personnel on channel 212, this OTC, discontinue all non-mandatory LDB traffic for remainder of count.
T-minus 10 minutes and counting, about 1 minute now from the last planned built-in hold in the STS-31 launch countdown this morning. The flow rate of the conditioned air fed into the orbiter's payload bay is being reduced and will be verified at about 180 pounds per minute, which is the figure desired for launch. Standing by now to go into the hold at T-minus 9, 3, 2, 1, T-minus 9 minutes and holding for 10 minutes. We will emerge from this hold at 8:22 Eastern Time. When the countdown resumes, the ground launch sequencer will be in control. The master computer program will issue the commands to perform all of the final critical tasks required to put the vehicle in its launch configuration. During that time, it will be monitoring as many as 1,000 different parameters in that last 9 minutes to make sure that they do not fall out of any predetermined limits that the launch team calls red lines. All personnel in firing room 1 have now switched over to the same communications channel, and they will be staying on that through launch.
This is NTD on 212, taking a status check for launch. Say go, no go for launch. OTC? Go. TVC? Go. PTC? Go. LPS? Go. Flight? Houston flight, NTD. Mala? Mala, NTD. FTM? FTM, let's go. Safety console. Would it be legal to call my lady?
Now about 2 minutes into the T-minus 9-minute built-in hold. We'll go now to Mission Control in Houston for a readiness statement, and also to the Space Telescope Operations Control Center at Goddard. They will report their readiness. Going now to Mission Control in Houston.
This is Mission Control Houston. Flight controllers in the Figure 1 room are ready for launch. The flight director for Ascent, Von Dittemore, just polled the room, and all positions reported they will be go for coming out of the T-minus 9-minute hold. One slight change to this morning's plans for launch. Ben Guerir will be designated as the prime transatlantic landing site with Banjul as backup due to a problem with the primary TACAN system at Banjul. The secondary TACAN system is operational, but since weather is good at both sites, we will be choosing Ben Guerir as the prime transatlantic landing site this morning. No other systems problems are reported, and all positions in Mission Control are standing by for launch. This is Mission Control Houston. We'll hand over now to Hubble Space Telescope Operations at Goddard.
Wheels, channel 118 X-ray.
This is Hubble Telescope Control Greenbelt. The Director of Orbital Verification, Mike Harrington, has confirmed that all control team positions here at the Space Telescope Operations Control Center in Maryland and the support team at the Huntsville Operations Support Center in Alabama are ready to support today's launch of the Hubble Space Telescope. Approximately 3 hours ago, the crew configured switches aboard the orbiter to provide essential power to 3 telescope systems. The telescope's receivers were powered to ensure that they are warm and on frequency to receive initial commands from the control center following launch. Heaters for the rate sensing units were powered to maintain the gyros at a stable temperature, and power was applied to the fixed head star tracker shutters to ensure that they remain closed during launch. Otherwise, the telescope is essentially powered down in Discovery's cargo bay and ready for launch. Beginning approximately 4.5 hours after launch, controllers here will begin sending commands to systematically activate the telescope systems in preparation for tomorrow's scheduled deployment. Again, all is ready here in the control center at Goddard Space Flight Center, Greenbelt, Maryland, and at the support center at the Marshall Space Flight Center in Huntsville, Alabama, for today's launch of the Hubble Space Telescope. At T-minus 9 minutes and holding, this is Hubble Telescope Control Greenbelt, returning now to the Launch Control Center.
This is Shuttle Launch Control in Firing Room 1 of the Launch Control Center at KSC, where we have approximately 5 minutes remaining in the T-minus 9-minute built-in hold. Several milestones remain between now and launch. As we come out of the hold, the ground launch sequencer will take over control and issue commands for the final critical tasks and monitor the hundreds of vehicle measurements that are coming in during the final 9 minutes. At T-minus 7 minutes 30 seconds, the orbiter access arm retraction will be performed.
No constrained explained condition.
And at T-minus 5 minutes, pilot Charlie Bolden will start up the orbiter's auxiliary power units.
SMS D as in dog.
A gimbal check of the orbiter's aerosurfaces will occur at T-minus 3 minutes 55 seconds. And switch over to internal power occurs at T-minus 3 minutes 30 seconds. And then the orbiter's main engines will be gimbaled or moved at the T-minus 3 minute 25 second mark. LOX tank pressurization and retraction of the GOX vent hood will start at T-minus 2 minutes 55 seconds, and the liquid hydrogen tank will be pressurized for flight at T-minus 1 minute 57 seconds.
Launch director, with that, the team is ready to proceed. That's step 1016. Okay, I'll conduct my poll at this time. Payload operations director. Launch director, payloads are go. Copy, engineering director. Engineering is go. Copy, safety and quality director.
Safety and quality go, boss.
Copy, Cape weather.
Yeah, no weather launch constraints violated. Launch wind forecast from 09 to 0 degrees at 10 knots.
I copy, operations manager.
Bob, we have no constraints, and you are go to proceed with the launch.
Copy, thank you, sir. Discovery launch director. Air to ground.
Discovery, go ahead.
Okay, well, at the risk of being repetitious, we're here again, and everything looks good. Shuttle, ground systems, and the Hubble, and we believe the universe is still go. So we hope we can get you up there to take a look at it today. Have a good one.
Okay, we sure do. Thank you very much. Looks like it's been a good countdown here.
Yes, sir, and MTD, you have go to proceed.
I understand, thank you. Flight, ISL, RPS, NTD.
Just flying.
ISL.
This is ISL.
JRPS.
JRPS.
Okay, step 1012, you can activate recorders. Copy.
DVD OTC.
This DVD, go ahead.
Okay, we have a payload bay purge rate set for launch at this time.
That's the firm we just completed. It's stable at 178.
Copy that.
With it outperformed on step 1009.
Copy that.
NTD flight recorders have been activated.
Copy. Countdown clock will start in 2 minutes. ISL, did you copy that the recorders are active?
NTD, CNSE.
Go ahead, CNSE.
Yeah, overheard changing tail sights to 118 X-ray.
That's firm. And we're now Ben Guerrero.
And they changed those sun wheels yet?
That's firm.
Copy.
1 minute and 30 seconds from picking up the countdown at T-9, where we will press on toward the handoff of the ground launch sequencer to Discovery. The onboard computers will then start their own automatic sequence, and the final commands will come at T-minus 10 seconds to provide the concurrence for a go for main engine start. The engine start will occur at T-minus 6.6 seconds and solid rocket booster ignition at T0. The orbiter's computers will issue the commands to start, and the ground launch sequencer will concur. 45 seconds now to picking up the countdown. "30 seconds away from picking up at T-9. Nothing is reported amiss, and we are go for picking up the count in 10 seconds.
Countdown clock will resume on my mark. 5, 4, 3, 2, 1, mark. TLS auto sequence has been initiated.
Now into the final phase of this morning's launch countdown with the initiation of the ground launch sequencer. Standing by now for a request from the orbiter test conductor to Houston Flight to send stored program commands, which are the final update on the antenna alignment.
PLT was that, OTC was that for the PLT.
That's affirmative. Configure fuel cell central bus source switches, please.
That's in work, Stan.
Thank you.
OTC PLT, essential bus connection is complete.
Copy that, thank you.
Next significant event coming very shortly here with the orbiter crew access arm being retracted away from the vehicle into the launch configuration. This arm can be re-extended in less than half a minute if that's necessary. T-minus 7 minutes, 30 seconds and counting.
TLS's go for orbiter access arm retract.
In about 45 seconds, the orbiter test conductor will give pilot Charlie Bolden a go to perform the auxiliary power unit pre-start. Bolden will configure switches in the cockpit to put the APUs in the ready-to-start configuration. The APUs will be started at T-minus 5 minutes. Go for APU pre-start will come in about 10 seconds.
You want to start your APU on hydraulic strip chart recorders, please. Recorder started. And PLT OTC.
Go ahead.
You can perform your APU pre-start, please.
That's in work.
The APUs provide hydraulic power to the orbiter. Standing by for confirmation that the APU pre-start is complete.
Pre-start's complete. 3 great talkbacks.
Thank you, Charlie.
Pilot Bolden reporting back that the pre-start operations are complete. T-minus 5 minutes 30 seconds. Mission Control has transmitted the signal to start the flight recorders. The 2 recorders will collect measurements of the shuttle system's performance during the flight for playback later after the vehicle is in orbit. Coming up on T-minus 5 minutes and counting.
TLS's go for orbiter APU start.
And we have a go for APU start.
APUs, please.
That's in work, Stanley.
And CDR OTC.
Go ahead.
You can reconfigure heaters, please.
Commander Schreiber asked to reconfigure the orbiter heaters. He'll report when that's complete.
Heaters are reconfigured.
Thank you.
The ground launch sequencer has terminated liquid oxygen replenish to the external tank and is now initiating the LOX drain back.
And OTC, PLT, APU start is complete, and so far so good.
There are the good words. 3 APUs in good health. About to start a profile test. Profile test of the orbiter's aero surfaces. The orbiter flight control surfaces are being moved through a pre-programmed pattern. And we'll have a gimbling of the main engines, which will follow. Final purge sequence of the main engines is in work. We're now transferring to internal power and switching off the orbiter's ground power supply. At this point, Discovery is being powered by the onboard fuel cells. T-minus 3 minutes and counting.
TLS's go for ET-LO2 pressurization.
Go for pressurizing the external tank. All systems are go for launch.
OTC 212.
Go ahead, OTC.
Okay, clear caution and warning memory and verify no unexpected errors.
Okay, we have no caution and warning annunciation, Stan. That's
Okay.
complete.
Thank you, Charlie.
Standing by now, here is the retraction of the gaseous oxygen vent hood. The gimbling of the main engines is complete, and the aero surfaces have been verified that they are positioned for launch. The external tank now is reported to be at flight pressure.
OTC 212. close and lock your visors and initiate your O2 flow, and you all have a good trip.
Roger that. 10 work.
Let's just go for ET LH2 pressurization.
Bringing the LH2 pressurization up to flight levels. 90 seconds away from launch now.
1 minute, 30 seconds.
And the LH2 tank now reported at flight pressure. Both tanks, liquid and oxygen, now ready to flow propellants. Sound suppression water system is now being armed, which will flow water onto the mobile launcher platform at the rate of 900,000 gallons a minute, beginning at T-minus 16 seconds. The heaters on the booster joints are now being turned off. The orbiter computers have positioned the vent doors to the launch configuration. Standing by now for a go for auto sequence start. T-minus 33.
Countdown clock will hold at T-minus 31 seconds due to failure.
We've had a hold. We do not know at this time what the problem is. We'll be standing by for word, but the clock is holding at T-minus 31 seconds due to a system failure.
And NTDSD, it's the LO2 outboard fill and drain valve. NTD is CMPL. Go ahead. It's LCC MTS 8. And PV9 outboard fill and drain closed power is off. It should be on.
A recommendation?
And NTD, that we're in a no-go situation. We should have our open power, and we do not. Or excuse me, our closed power.
SP?
And MPS, can we verify that the valve is closed? Negative. We right now show a open position. We cannot verify the valve is closed.
SP, this is CMPS.
Go MPS.
The way that LCC reads, if we have the closed power on and the open position off, we can cycle one time and try to pick up the closed position, but we never picked up the closed power.
Okay, in MPS, we have a message that we were blocked by a prerequisite sequence, GCL 18.
What has happened is the ground launch sequencer would not hand off to the orbiter's computers to complete the count because the liquid oxygen fill and drain valve was showing off when it should be on. An analysis of the problem has begun.
We've been holding 2 minutes.
SDE, this is CMPS. We're going to make an attempt to pressure that valve closed. We've got the prereq set off. If this works, we should be in good shape.
I copy. Proceed.
It work?
We have 7 minutes of runtime available on the auxiliary power units. We've been holding now about 2 minutes and 20 seconds.
NTD, this is CMPS. The valve's closed. We're go.
There's the confirmation that we have successfully
Okay, and you're in the process
recycled.
of configuring the pickup terminal sequence MPS.
That's affirmative, so we're go. We're in good shape.
Okay, you have a go to proceed.
GLS, pick up the count immediately.
I copy. Mark. GLS, let's go for auto sequence start.
We are go for start.
25.
Booster hydraulic power units have started.
20.
Sound suppression water system has started.
15.
T-minus 13 seconds.
10.
T-minus 10. Go for main engine start. We are go for main engine start. T-minus 6, 5, 4, 3, 2, 1, and liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Mission Control, Houston.
Roger, roll, Discovery.
The roll maneuver puts the vehicle in the proper launch plane. Guidance officer confirms a good roll maneuver. Engines now throttling back. The throttle down maneuver assists in reducing the aerodynamic loads on Discovery as it passes through the area of maximum dynamic pressure. Velocity now 1,200 feet per second. Discovery downrange 3 nautical miles.
Discovery, go at throttle up.
All 3 engines now throttled back up.
Go at throttle up.
Engines at 104%. The go at throttle up call signifies that all systems are performing well. All 3 auxiliary power units look good. Discovery's velocity now 2,300 feet per second and is downrange 8 nautical miles. Standing by for SRB separation. And both solid rocket boosters have separated. Discovery's velocity now 4,300 feet per second at a downrange distance of 35 nautical miles. Booster officer reports all 3 engines stable at 104% performance.
Discovery Houston, performance is nominal. And Discovery 2-engine Ben Guerrier.
The 2-engine Ben Guerrier call means that Discovery could reach the transatlantic abort site at Ben Guerrier on 2 engines if it were necessary.
Copy, nominal performance, 2-engine Ben.
Velocity now 5,000 feet per second. Discovery 60 nautical miles away from the launch site. All systems continuing to perform well aboard Discovery. Velocity now is 6,200 feet per second. Downrange 100 nautical miles. The Environmental Systems Officer reports the FES is operating well. That is the flash evaporator system that provides cooling to Discovery's systems.
Discovery Houston, negative return, press to ATO, select Banjul.
Negative return, press to ATO.
That last call means that Discovery cannot return to the launch site at Kennedy. However, enough energy has been achieved to reach a safe orbit on 2 engines should one shut down, and Discovery could also reach the backup transatlantic abort site at Banjul if that were necessary. All 3 engines are stable at 104%. Auxiliary power units all performing well. Discovery's velocity is 8,400 feet per second at a downrange distance of 175 nautical miles.
Discovery, press to MECO.
Press to MECO.
The press to MECO call signifies that Discovery could make the main engine cutoff targets.
Discovery, droop band jewel 109.
Droop 109.
And that last call means that Discovery could reach the Banjul transatlantic site on one engine at 109%. All three engines still looking good. Discovery's velocity 12,000 feet per second. Downrange 290 nautical miles at an altitude of 60 nautical miles. Guidance officer confirms that navigation is good.
Discovery, single engine Banjul 104.
Single engine Banjul 104.
Booster officer reports all three engines stable.
Houston, single engine press 104.
The single engine press call means that Discovery could make it to main engine cutoff targets on one engine at 104%. Discovery's velocity now 16,000 feet per second at an altitude of 58 nautical miles, downrange 435 nautical miles.
Discovery, late call, single engine press 104.
Roger. Fuel cell pH, we expect it.
Discovery Houston, concur, no action on fuel cell pH.
No action is required, no impact on that pH message. That message was expected during this phase of the launch. Velocity now 19,000 feet per second. Three engines throttling back now to maintain the 3G limits on the vehicle. Discovery is 580 miles away from Kennedy at an altitude of 56 nautical miles. We are standing by for main engine cutoff at 8 minutes 32 seconds mission elapsed time.
Good MECO, looks nominal from here.
And the booster officer also confirms a nominal main engine cutoff.
Discovery, we see ET-SEP. Nominal MECO, ohms 1 is not required.
The booster officer has also confirmed.
No ohms 1 required.
This is mission control. The booster officer confirms good separation from the external tank, and the flight dynamics officer confirms good performance on both phases of the ascent. No orbital maneuvering systems 1 burn is required.
Discovery Houston, for info, we've had some problems out at White Sands, but we anticipate a nominal handover to Tidris at 11+30.
And Houston, we copy, and we had left L3A tail off during the +5 second dump.
Roger that, Discovery. We see it. No action for you now. We're still evaluating.
This is Mission Control. The ground control officer does not expect any loss of communications capability with the crew. We will be handing over to the tracking data relay satellite at about 11.5 minutes mission elapsed time. There have been some minor problems at the White Sands ground station, but they expect no particular impact from that. Booster officer reports that we see data indicating the main propulsion system dump is in progress. This procedure vents any remaining fuel or gases that may have resided in the engines at the end of their burn, just to make sure that those gases are vented out of the system and not present any problems for the remainder of the mission.
Discovery Houston.
Discovery, we're standing by. Go ahead.
Roger that, alarm. We're back with you through Tidris. Expect nominal ohms 2. Anticipated delta V 4, 9, or 5.
Okay, we copy and standing by on your go for APU shutdown.
Roger that, Discovery. Stand by. Discovery Houston, go for APU shutdown.
Roger.
This is Mission Control. The crew has received the go to shut down the auxiliary power units. And they've been informed also that the normal Orbital Maneuvering Systems 2 burn will be done on time, which is scheduled for 42 minutes, 39 seconds mission elapsed time. Change in velocity will be 495 feet per second, and that burn will put Discovery in an orbit of 330 by 310 nautical miles. This is Mission Control. Mechanical Systems Officer reports that the APU shutdown was normal, that the procedure looked good, and the configuration of the auxiliary power units looks good. This is Mission Control. The MAX officer reports indications that the external tank doors are closing aboard Discovery. Crew is right on time, following through the post-insertion timeline, or the post-ascent checklist, and at about 50 minutes mission elapsed time, just short of an hour, they will begin procedures in the post-insertion timeline. MAX officer confirms that the external tank doors are closed and latched.
Discovery Houston, while you're on the way to Attitude, if you've got a spare moment, we'd appreciate a debris report.
Okay, Steve, stand by 1. Houston Discovery, for debris on the way uphill, right in the about from a minute and a half to 2, Charlie and I noticed several flecks of things impacted the forward windscreen. They seem to be pretty soft and just leave little streaks. SRB SEP put a pretty good little cloud on all the windows. And here at Vacuum Inerting Terminate, we see lots of ice particles, but that's all normal. And between SRB SEP and Mika, we didn't really see that much debris that we can recall.
Okay, roger that, Discovery. Appreciate the report.
This is Mission Control. A guidance officer has reported that Discovery has almost completed the maneuver to the position for the Orbital Maneuvering Systems 2 burn. That burn is scheduled about 16 minutes from now at 42 minutes mission elapsed time. and that ohms burn will have a change in velocity of 495 feet per second, and will raise the low point of Discovery's orbit to 310 nautical miles.
Discovery Houston, we see you in burn attitude and your targets look good.
Roger that, Houston. Hang on, Houston, Discovery, we see the tank and burn attitude down below us. It looks like it's straight down below us between us and Africa.
Roger that, Lauren, we copy, and about how far away do you think it is?
On the long axis, it would probably be about a 6 or 7 mil radius on the coax.
Roger that. Thank you very much.
This is Mission Control. The guidance officer has seen the data indicating that Discovery is in the proper position for the OMS 2 burn. And Commander Lauren Shriver was discussing with Capcom Steve Oswald that the crew could see the external tank below them on its way to the impact area.
And Houston, Discovery, are you still with us?
That's affirmative, Discovery. You're loud and clear.
Okay, as we've been coasting here, we've just been watching the external tank tumble, I don't know, 4 or 5 times since we called you last.
Roger that. Must be a beautiful view. Discovery Houston with some words on your burn.
Go ahead.
Roger, Lawrence, since we lost L3A, if you should lose an engine during the OMS 2 burn, an OMS engine, we want you to terminate the burn at an HP of 85.
Okay, we copy.
This is Mission Control. That last note given to the crew refers to the small reaction control jet number L3A, which failed off shortly after the ascent phase was completed. Propulsion officer thinks that that was due to a valve failure, perhaps in the oxygen valve system of that small RCS jet. Therefore, the crew's just been given a little note to change their procedure card. If during the upcoming Orbital Maneuvering Systems 2 burn, they should have an OMS engine failure, they would terminate the burn at an altitude, perigee altitude of 85 nautical miles in order to give flight controllers time to assess the situation and see what action should be taken at that point. We'll be coming up in about 2.5 minutes on the time of ignition for the OMS 2 burn. Once again, that's at 42 minutes, 36 seconds mission elapsed time. Delta velocity for the burn is 495 feet per second. Should raise the perigee of Discovery's orbit, or the low point of Discovery's orbit, to 310 nautical miles, resulting in a final orbit of 330 by 310 nautical miles. This is Mission Control.